Hi, Geometry. This is construction number 10. It's in Unit 1, Lesson 7, which is page 48 of our math workbooks. So it asks us to use our compass and straight edge to construct a square inscribed inside of a circle. That means all four vertices will be on the circle. That's what it means to be inscribed. All four vertices touch my circle. So the first thing we're going to do for this construction is we're going to draw a diameter. So grab your straight edge and draw your diameter. And you can draw your diameter anywhere. If you want your construction to look like mine, maybe do kind of a diagonal that moves down from left up to right. Any diameter you want, mark the end points of your diameter. Diameter goes to the center. And now step 2 is we're going to construct perpendicular bisector of this diameter. Remember, that's construction number 1, perpendicular bisector. So I'm going to set my compass. Really, anything more than halfway works. So this distance would be fine. It's past the center point. That distance is fine. This one's fine. But I'm going to go all the way over because this is how we did construction 1. I'm just going to use the entire distance. So I'm going to draw a circle at the end point on my left side. Draw a big circle here. I'm going to move my pointer to the other side and draw a big circle. We've done this construction multiple times at this point. So, and when I do that, I have 2 intersection points. This one up here and this one down here. So now I would like to draw in that perpendicular bisector. So first off, let me do this in pencil because there's only a portion of this perpendicular bisector I'm actually that interested in. So the entire perpendicular bisector is this penciled line that you see here. However, the part that I'm really interested in is the part of the perpendicular bisector that is intersecting my circle. So really when you do this, you need the segment or the part of the perpendicular bisector that is the other diameter. These two diameters are perpendicular to each other because what I just constructed was a perpendicular bisector. And I have 4 points on my circle. Those are the 4 points I want to join. Ignore this point and this point. For some of you, depending on how you set your compass, it's inside the circle. Some of you, it might be really close to being on the circle. Others of you, it's out here. Where your intersection points are don't matter. But the points that you're interested in are the ones on the circle that you get when you draw in that perpendicular bisector. So let's join the 4 points on the circle. And when I do that, I have constructed my square that's inscribed, meaning inside my circle. So this is my square. And so I have 4 equal sides, if it's a square, inside my circle. Let's take a look at the next page, page 49. On this page, you will see a few shapes here. It says we can use what we know about perpendicular lines and congruent segments to construct many different objects. A square is made by 4 congruent segments that create 4 right angles. A square is an example of a regular polygon. Since it has all sides congruent and all angles congruent. Equilateral, all sides congruent. Equal angular, all angles congruent. These are some other regular polygons inscribed in a circle. We have already done this one. This was an equilateral triangle. That was a construction that you and I already did together. This was the square. You and I just did this construction. This is a pentagon. We've not done this one. This is a hexagon, 6 sides. You and I have already done this construction. All 6 of these sides are congruent. And I believe, does this 1, 2, 3, 4, 5, 6, 7. This is a heptagon. Of course, you have octagon, nonagon, decagon. And of course, you have polygon, poly meaning many, but that's coming up later in our book. But these are all regular polygons because their sides are congruent, and they're all inscribed, meaning they're inside the circle. Thank you.